Hello guys, in this video I'm going to explain the chain rule and show you some examples and applications of it. So the chain rule is used when you have a function of a function. So let's say f of x is equal to g of h of x, right? So for example, we could say it's e to the, no, not e. Say it's like x plus 3 squared, right? This would be our h of x, and this outer bracket would be our g of x, right? If you want to take the derivative of this, it would be the derivative of the outside function, so derivative of g, and then the inside will stay the same, and then multiplied by the derivative of the inside. So as an example, it would be the derivative of this term squared and then the derivative of the inside. So I think it's easier to understand through some examples. In this one, you could use quotient rule, but quotient rule is annoying, so let's use chain rule. And one thing to note is for chain rule, you need to use the other rules. So in applying chain rule, you may need to apply quotient rule, product rule, and power rule. So if we want to do chain rule, we'll have to do this. So now we have a function of a function. Our outside function is this to the power of 5, negative 5. This isn't f prime, so we got f prime of x now. Negative 4 is going to be here still. We have a negative 5 now times the derivative of the inside. So, no, my bad, not the derivative of the inside. So we put the inside again. And then we multiply by the derivative of the inside. So 3 plus 2x plus 6x squared. That would be the derivative, right? Okay, so this one, let's rewrite it so it's easier. Negative 3 plus 2x minus 3x cubed times 2, oops. Okay, all to the power of 0.5. So now let's take the derivative of it. Oh, this one's going to be a long derivative, so let's just move this up a little bit so that it doesn't get in the way. All right, put an arrow. Okay, so we got to take the derivative of the outside first, 0.5. Now we got to copy the inside. Negative 3 plus 2x minus 3x cubed, negative 2x plus 2x squared to the negative 0.5. Now the derivative of the inside, which is just going to be these terms. And so for that, we just use a product rule, right? So the derivative first one, 2 minus 9x squared times negative 2x plus 2x squared plus, now we just rewrite the first part. It's 2x minus 3x cubed. Derivative of the second part, negative 2 plus 4x. And that's that derivative. You could factor, and you could you factor? Yeah, you could factor and multiply out and collect like terms and waste the time. You don't need to unless it's required of you, but then that just becomes algebra. This one, let's see. Okay, so we could use quotient rule for this. We could use double chain rule, or we could use chain rule quotient rule, right? Because we have a chain right here with this root, but then we have a quotient inside. Or we could just bring this up, so it would be chain rule outside, product rule and chain rule on the inside. In my opinion, the product rule, so as a result of bringing this up and then chain ruling it, is a lot simpler. So I'm going to go with that method because the quotient rule is just very messy. So let's rewrite it nicer. negative 1 plus x minus x squared times 2 minus 2x minus x squared to the negative 1, close bracket, 0.5. So now you see what I mean? You chain rule this, and then once you're doing the product rule of the inside, you're going to have to use chain rule one more time. So double chain rule. Alright, so 0.5 times... Now let's write all the inside, all the good stuff on the inside. Remember to keep track of your brackets. Times 2 minus 2x squared to the negative 1 to the negative 0.5 from the power rule, right? Then multiply this by the derivative of the inside. So derivative of the first part first. It'll be just 1 minus 2x times, okay, we gotta put a big bracket here. I don't like how that looks. We gotta make sure it does not become messy or it's going to be very hard to read, especially on a test. You don't want to be wasting time trying to read your own writing. So 1 minus 2x, yeah. Now we multiply it by the bottom one. So x squared to the negative 1 plus, now the first part, negative 1 plus x minus x squared. Now we're taking the derivative of it, so this will be negative, right? We multiply. Actually, let me do it so it's easy. Times negative 1 times, now we rewrite this, 2 minus 2x minus x squared, negative 2, then times negative 2 minus 2x, right? That's just a chain rule being applied a second time. That's the derivative of that. Let's move this one down. Should be a short one. I'm going to highlight the answer. This is the answer. Right. For this one, what is this? This one's easy. This one's just the chain rule needs to be applied twice. Again, so prime of x, gotta product roll this. So 3 times 2 minus x squared times negative 2x. That's the derivative of the first part, right? Now we just multiply it by the other half of the function. Now moving on, 2 minus x squared cubed times the derivative of this using the chain rule, so times 3 minus 2x squared times negative 4x. That's your derivative. All right, this one now. Okay. First, let's actually rewrite it. I hate seeing radicals like that. It's very confusing to me, at least, so I like to rewrite them. Negative 1 plus 2x instead of 1 over 3, right? Now, this is just going to be similar to the previous example, but chain rule once and product rule first. Negative 1 plus 2x, right? Now we just multiply it by the second half. Plus, put the first part. So times 1 over 3. Negative 1 plus 2x minus 2x squared. So, and then the exponent, 1 over 3 minus 1. So 1 over 3 minus 3 over 3. We're going to get negative 2 over 3, right? Easy way of doing it. Don't do these in your head unless you're very proficient. But even then, I never do them because it's always a chance for a mistake if you don't write it down. Just good to show your work, you know? Now we multiply it by the derivative of the inside. 2 minus 4x. And that is your answer. So yeah, the chain rule is good when you have a function of a function. Where did it go? Right here. Function of a function. It could get very messy, but so that's why it's important to keep track of your brackets. And here's a little tip. Chain rule is just a way of interpreting it, right? So you could have product rule going into chain rule, right? And then using like chain rule and power rule go hand to hand, by the way. Because you see what we did, like it's just like the power comes down, we take the term, so we would take this term as a variable rather than a term itself. That's why we can use the power rule on it. But and then you could have like quotient rule after, right? So these could be in any order. It's just do it in the order that is the easiest, because that way it would waste the least time. Otherwise, if you have any questions, put them in the comments, and have a good day.